There is a video going around right now claiming you can bury a coil of black poly pipe in the ground and get free drinking water out of the end of it. Out of the air. No creek, no well, no rain. Just a pipe in the dirt making water. I'm going to tell you exactly how much water that gets you, and then I'm going to show you the thing people should actually be doing with black poly pipe. Which is a real technique. It does produce real water year-round, almost nobody talks about it, and it costs about as much as a nice dinner. Subscribe if you want more of this kind of thing. I spend most of my life walking ground, and this is the sort of stuff you notice out there. So let's do the air one first, because I want it out of the way. The idea is condensation. Warm air holds moisture, cool surfaces make that moisture come out of the air as liquid, and the ground a few feet down stays cool all summer. So run pipe through the cool ground, air moves through it, water condenses on the inside, runs downhill, comes out the low end. And I want to be fair here. Every single step of that is real physics. Your bathroom mirror does it. The outside of a cold glass does it. There's nothing fake about the mechanism. The problem is the amount. People have been chasing water out of the air for a very long time, and there's a famous case worth knowing about. Back around 1912, a Russian forester named Siebold built an enormous stone condenser in Crimea. A cone of pebbles about 30 feet tall sitting on the better part of an acre. Because he was convinced some ancient ruins nearby had been doing exactly this. The number that got repeated for decades was that it produced something like 55,000 liters a day, which would be extraordinary. When people went back and actually looked at it, the real figure was around 360 liters a day. And even that came from a pile of rock roughly the size of a small pasture. That's the whole history of this idea in one story. The mechanism works. The mechanism just doesn't work very hard. Now for the modern number, because this is the one that matters. Researchers have measured passive dew collection about every way you can all over the world. And the theoretical ceiling everybody keeps landing on is somewhere around 700 milliliters per square meter per day. Under good conditions, that's less than a quart of water off a square meter of collecting surface on a good night. Now go picture the black poly pipe. Think about how much surface area is actually inside one length of pipe. 100 feet of inch and a quarter pipe has maybe 3 square meters of interior surface, total, and that's the whole surface, not the part that's actually cold enough at any given moment. There are real studies on buried pipe condensation, and they get useful yields, a few liters a day. But read what they're actually doing. They're running humid air through that pipe on purpose. Air that's been deliberately saturated first, usually by a solar still, and forced through with a fan. That's a machine. That's a whole system with an energy input built to do this one job, and the pipe is just the heat exchanger inside it. A coil of pipe buried in your yard with no fan and no humidifier and both ends open to whatever the weather feels like doing has none of that. Air doesn't move through it. Nothing drives the process. You will get some dampness on the inside of the pipe, and in a humid climate, you might collect a few tablespoons on a good morning. And every one of those videos ends before they show you a measuring cup. There's one more thing that kills it. And it's the cruelest part. The places where people most want free water are dry places. In dry places, the dew point is low, sometimes below the ground temperature, sometimes below freezing. So the drier your climate, the less this works, right when you need it most. The physics is actively unhelpful. And there's a self-defeating problem underneath all of it that the old stone condenser builders ran into and never solved. To condense water, you need a cold surface. But any surface that's massive enough to hold cold through the night is also massive enough to soak up heat all day. Siebold's rock pile absorbed a whole day of sun and then couldn't shed it fast enough after dark to drop below the dew point for long. Your buried pipe has the opposite version of the same problem. The soil around it is cool, sure, but soil is also a fantastic insulator, which means as soon as a little warm air gives up its heat to that pipe, the heat sits there. The ground right around the pipe warms up and the condensing stops. Then you're waiting on the whole mass of the earth to carry that heat away, which it does about as slowly as you'd expect dirt to do anything. That's why the working versions have a fan. You need volume of air moving past, constantly, and you need something actively hauling the heat off. Take those away, and you don't have a slower version of the same machine. You have a damp pipe. So that's the amazing invention. Now let me tell you about the actual amazing invention, the one that deserves the billing, and which does use black poly pipe. It's called developing a seep. Here's the thing most people never think about. Groundwater is not a lake sitting under your property. It moves. It soaks down through soil until it hits a layer it can't get through. Clay, hardpan, bedrock, something dense, and then it stops going down and starts going sideways, running along the top of that layer, downhill, following the slope. And it does that constantly, year-round, in ground that looks completely dry from the top. Where that impervious layer comes near the surface, water piles up against it and oozes out. That's a seep. And if it comes out of one defined spot with any force, we call it a spring, and everybody notices it. But most of them don't do that. Most of them ooze out over a broad, wet area with no obvious source, and people walk past them their entire lives thinking that's just a soggy patch. The way you get one is usually pretty simple once you picture it. Rain falls on the high ground above you, it soaks in, works its way down through whatever's up there, and eventually meets a layer it can't get through. Now it's got nowhere to go but sideways, so it starts running along the top of that layer, downhill, in the dark, sometimes for hundreds of yards. And wherever the ground surface happens to cut down and intersect that layer, a road cut, a bench in the hillside, the head of a draw, the water arrives at daylight and comes out. It didn't come from directly underneath. It came from up the hill, and it's been traveling the whole time. That soggy patch is a water source. Nobody developed it because it doesn't look like anything. So how do you find one? And this is where I want to give you the single most useful thing in this video, which I got from my grandfather, Walt. Look in August. Anybody can find wet ground in February. In February, all the ground is wet, and every low spot on the place has water sitting in it that came out of the sky last week. That tells you nothing. But in the dry end of summer, when it hasn't rained in 6 weeks and everything on the hillside has gone brown and crispy, the ground can't hide anymore. Walt used to say the ground tells on itself in August. Whatever's still green in August is green because something is feeding it from underneath. So you walk your slopes late in the dry season and you look for green where green has no business being. A patch of ferns halfway up a dry hillside. Rushes, sedges, horsetail, skunk cabbage, plants that need constant moisture, growing somewhere that gets no constant moisture from above. A stand of willow or alder in the middle of country that's all fir. Moss that's still soft when everything around it crumbles. Look for game trails converging. Deer know where the water is, and they know it a lot better than you do, and their trails will braid together and head for a spot for no reason you can see. There's a winter version of this, too, if you get snow. A seep is groundwater, and groundwater comes out at the temperature of the ground rather than the temperature of the air, cool in August, and relatively warm in January. So after a light snow, look for the bare spots. A patch of ground that stays open when everything around it is white is telling you the same thing the green patch told you in August, just from the other direction. Same with frost on a cold, clear morning. The seep won't take it. And use your hands and your feet. Ground over a seep feels different, it gives a little, it's cool. And on a hot afternoon, you can sometimes feel the temperature change through your boots when you step onto it. Take a piece of rebar or a long screwdriver and push it into the ground in a few places. Where it's easy to push and comes up wet and dark, you're onto something. Where you hit something hard 3 feet down and the soil above it is damp. That hard thing is probably your impervious layer, and that damp soil is water running on top of it. That probing is worth doing methodically rather than randomly. Work across the slope in a line, a few feet apart, and pay attention to how deep you're getting before you hit resistance. What you're really mapping is the shape of that hard layer underneath, where it's deep, where it comes up close to the surface, and where it forms a low spot that's funneling water toward one place. Ground that looks perfectly uniform from up top can have a whole drainage running through it 3 feet down, and a length of rebar and 20 minutes will show you more about your property than a day of looking at it will. Then you dig test holes uphill from the wet spot, not in it, uphill from it. What you're looking for is the point where that impervious layer sits about 3 feet down, with wet soil or gravel above it. That's your target. That's where you're going to intercept the water before it ever reaches the surface, which matters both for volume and for cleanliness. I want to say plainly what's happening here, because it's the part that makes this an honest technique and not a magic trick. You are not creating water. That water was already there, already moving downhill through the ground, already headed wherever it was headed. All you're doing is putting something in its path and giving it an easier route. It's the same principle as my family's old gravity system, which I've made a video about. Everything works because it was already going that direction, and we just got out of the way and made it convenient. All right, the build. You dig a trench across the slope. Across, not up and down, you're building a wall in the path of water that's moving sideways through the soil. So, it has to run perpendicular to the flow, roughly 2 feet wide, and dug down about 6 inches into that impervious layer so water can't sneak underneath. And extend it 4 to 6 feet past the wet area on both ends, because the flow is wider than the wet spot shows. That trench, when you're digging it, will start filling with water. That's how you know you found it. That's a good afternoon. While you're standing there looking at it, measure what you've got, because this is the number that decides everything downstream and almost nobody bothers. Scoop out a spot, let it run into it, and time how long it takes to fill a gallon bucket. That's it. That's the whole measurement. And the numbers are more forgiving than people expect, because a seep works around the clock. 1 gallon a minute, which is a modest trickle, nothing impressive to look at, is 1,400 gallons a day. That is an enormous amount of water for a household. Even a 1/4 gallon a minute, which is barely more than a steady dribble, still runs 360 gallons a day into a tank while you sleep. The catch is that you have to store it, because your demand comes in short spikes, and the supply comes in a thin, continuous line. That's what a tank is for, and it's why a small seep plus a big tank beats a big seep plus no tank every time. One safety thing before you get in that trench. 3 feet of wet soil on a slope is deeper than it sounds, and soil that's saturated will slough without warning. Bench the sides back rather than digging straight walls. Don't work alone in a hole over waist deep, and don't get in it at all if the sides are running. People die in trenches every year, and almost all of them were in a hole they'd described as not that deep. In the bottom goes your perforated pipe. 4-inch is standard for the collector, black poly, the flexible, perforated stuff. And here's the detail I see people get wrong constantly. The perforations go down. Not up. Water is coming to you along the bottom of that trench, along the impervious layer, and if your holes are up top, you're waiting for the trench to fill before any water gets in. Holes down, and it starts collecting immediately. Now the gravel, and don't cheap out here, use rounded river-run gravel 1 to 2 inch, not crushed rock. Rounded rock packs with big open voids between the stones and water moves through it freely. Crushed rock has flat faces that nest together and choke off the flow, and it'll pack tighter over the years. Bury that pipe in a minimum of 10 inches of gravel in every direction. That gravel envelope is doing as much work as the pipe is. It's a highway that pulls water in from a much wider area than the pipe alone ever could. Then wrap the whole gravel bed in filter fabric. All of it, sides and top. This is the step people skip and then wonder why their system silted up and quit in year 4. Without fabric, fine soil migrates down into your gravel every time it rains, and slowly, quietly, it plugs every void you built. The fabric lets water through and holds the dirt out. It's cheap, and it's the difference between a system that lasts 20 years and one that lasts 5. Line the trench with the fabric before the gravel goes in, leave plenty of overlap hanging out both sides, then fold it over the top once the rock's placed, like wrapping a package. Overlap the seams generously, a foot or more, because the fabric doesn't do anything at a gap. And it's worth buying real woven geotextile rather than the flimsy landscape cloth from the garden aisle. You're burying this. You are not going to want to dig it up in 6 years because you saved $11. Below the trench, on the downhill side, you build a cutoff wall. Compacted clay is fine. A proper installation might use concrete, but packed clay works, and it's free if you've got it. This is a barrier that stops water from just continuing on past your gravel and out the other side. It forces the water up into the collection bed and into your pipe instead of under it. The wall and the trench together make a little dam that the water has no way around except through your pipe. Key word there is compacted. Loose clay shoveled into place is just dirt, and water will find its way through it in a season. Put it in a few inches at a time and pack every lift before you add the next one. And tie the ends of that wall back into undisturbed ground past both ends of your trench, because water that can't get through a wall will happily go around the end of one. And then you've built a very expensive way to make the wet spot move 10 feet sideways. Off the low end of the collector, you transition to solid pipe. Solid black poly, sized for whatever flow you've got, running downhill to wherever you want the water. That's your delivery line, and there's nothing clever about it. It's gravity from there on, same as any other line. Then backfill the top with a tight soil, ideally clay-ish rather than sandy, and cap it with topsoil. You want surface water shedding off the top of your installation, not soaking down into it. That's a contamination path you're closing off. And here's where I want to hear from you. Comment and tell me whether you've got a spot like this on your place. The green patch in August, the game trails, the corner that's always soft. I'd bet a fair number of you are sitting on one and have never thought about it as anything but a nuisance. Now, where does that water go when it comes out the pipe? You want a spring box, or something doing that job. It's a covered container that the water runs into, sized so the water slows down in it, which lets sand and sediment settle to the bottom instead of going down your line. It needs a tight lid, because the entire point is keeping surface water, bugs, and animals out of what you just went to the trouble of collecting cleanly underground. 3 things that box needs, and the third one people forget. An outlet down low for your delivery line, set a few inches up off the floor so the sediment that settles has somewhere to sit without going down the pipe. A clean out so you can flush that sediment out once or twice a year. And an overflow, a big one, Because if that box fills and backs up, the water backs up into your gravel bed. And once the gravel bed is full, water stops flowing into your pipe and starts finding its old route around your whole installation. A seep system has to run continuously. It's not a tank you fill. It's a stream you're borrowing from, and it has to be allowed to keep going. Screen the overflow and screen any vent with fine mesh and check it now and then. That overflow is an open pipe leading into your clean water, and mice, snakes, and yellow jackets all think that's a fine place to be. A 1/4 inch of hardware cloth is not fine enough. Go to window screen. Give some thought to freezing, too, depending on where you are. The water itself is coming out of the ground at ground temperature, so it's not going to freeze at the source. And moving water in a buried line is usually fine. Where you get in trouble is the box and the exposed fittings, and any spot where the line comes above grade. Bury the delivery line below your frost depth where you can, and where you can't, at least keep it running. A line with a trickle continuously moving through it is a lot harder to freeze than a full still one. Now the honest part, because I'm not going to sell you something without the limitations. Seeps are less reliable than a real spring. That's just true. A concentrated spring coming out of fractured rock usually has a big deep source behind it, and it runs all year. A seep is often shallow groundwater with a smaller catchment behind it, and some of them are strong in April and gone in September. Which means you need to watch it for a full year before you build anything that depends on it. Go look at it every month, especially the driest month, and see whether it's still going. Building a whole system in the spring on a seep that dries up in August is a very common disappointment. And write the numbers down. Same bucket, same watch, once a month, in a notebook. A year of that tells you 2 things you cannot get any other way: what your worst month actually delivers, and how fast the thing responds to rain. A seep that drops off within a week of the rain stopping is shallow and small, and you should plan around it accordingly. One that holds steady through a 6-week dry spell has real depth behind it, and you can lean on it a lot harder. Same wet patch on the surface, completely different sources underneath, and the only way to tell them apart is to have watched. Seeps are also more prone to contamination than concentrated springs, precisely because the water is shallow and hasn't traveled far through soil. So test it. Actually test it. A lab test for coliform and whatever else is common in your area. Not a look at it and a shrug. I did a whole video about the water safety myth, about clear and cold and moving meaning nothing, and I'm not going to repeat that argument here, but it applies double to a seep. Find out what's uphill of it, too. If there's pasture or a septic field or a road up there, that's your water's neighborhood before it got to you. And the one that catches people completely off guard? This may not be legally yours. Water law in this country is strange, and it splits roughly at the 100th meridian. In most eastern states, you've got riparian rights, which more or less come with the land. In most of the West, it's prior appropriation. First in time, first in right, where water rights are separate property from the dirt. And the fact that the water is on your ground doesn't automatically mean you may divert it. Somebody with an 1880s claim downstream may have a stronger right to that water than you do, standing right on top of it. Most states have some kind of exemption for small domestic or stock use, and a seep like this often falls inside it. But often is not always, and the amount, the use, and the paperwork all vary by state, and sometimes by watershed. One phone call to your state water agency before you dig, and you'll know. That's a much better afternoon than the one where somebody shows up after you've built it. There's a fairness argument in there too, and I'd rather say it than skip it. That water was going somewhere before you put a pipe in front of it. Downhill, into a draw, into a creek, feeding whatever lives in it and whoever's below you. On a small seep and a household's worth of use, that's a rounding error, and nobody's going to miss it. If you're taking everything a seep produces and the little draw below it goes dry in August for the first time in 100 years, that's a different situation, and it's one you'd notice if you were paying attention. Take what you need and let the rest keep going. That's not just neighborly. In a lot of places, it's the actual law. So that's the trade. The pipe in the air version costs you a weekend and 100 feet of poly and produces a damp pipe. The seep version costs you about the same money plus some gravel and some digging and can produce water every day for the rest of your life without a pump, without power, without anything to break. And I'd argue the finding is the better half anyway. Once you know to look for green in August, you can't stop seeing it. You'll be driving past a hillside in September and catch a patch of alder sitting in the middle of dry country and think there's water under there. It changes how a piece of ground reads to you. Walt could do it from the truck. I thought that was showing off. It wasn't. He'd just walked that country in August for 60 years, and he knew which spots stayed green. And after enough Augusts, that stops being a skill and starts being something you just know. I've got a spot on the north side of this property I've been watching for 2 summers now that I think is a real one. 3rd summer coming up. And if it's still green in August, I'm going to go dig into it and find out. That'll be a video. Until then, I'll put a couple up here for you. I'm Cole Ashford. Thank you for listening.